Today we're going to be looking at graphs of inverse functions. So last week we studied how to find inverse functions. This week we're going to be looking at what do their graphs look like, specifically in comparison to the original function. So let's just start with a pretty simple example. Graph the function f of x equals 2x minus 3, then find and graph its inverse. So with this it's going to be a pretty simple function. It's linear, y equals mx plus b. So let's see what the inverse of this linear function looks like. So let's start by graphing it. So for y equals 2x plus 3, that's just going to mean a y-intercept at negative 3 and a slope of 2. So rise 2, run 1, and then we'll try to draw a nice straight line there. So I'm just going to use that. And that line will look something like this, and there should be an arrow at both ends. So there's the original function, y equals 2x minus 3. Next, we need to find the inverse of this. So remember, we're starting with y equals 2x minus 3. To find the inverse, we're going to switch x and y. And now solve for y again. So we would add 3 on both sides to make it x plus 3 equals 2y, and then divide both sides by 2. So I'm just going to write this in y equals mx plus b form. So this would be 1/2 x plus 3/2. So y equals 1/2 x plus 3/2. That is the inverse function, f inverse of x, equals 1/2 x plus 3/2. So now we found the inverse, let's graph the inverse. So I'll do that in blue. So it's got a y-intercept of 3/2 or 1.5, so that will be there. And then its slope is 1/2, so rise 1 up to 2.5 and run 2. And let me draw a blue line in there. So what you can see here is we have two lines that are intersecting. So they're not parallel, but they're also not perpendicular. They don't intersect at right angles. So what is the relationship here? Well, what we can actually see is these lines are a reflection of each other. They're a mirror image. We just need to figure out what they are a reflection over, where the mirror is. So it looks like it's going to come kind of right down the middle of where the two lines intersect, would be our line of reflection. So if I just draw kind of a dotted line in here, these are actually a perfect reflection over this diagonal line. So you can see this point that was here at, let's just take this intercept point at 0, 1.5 has a corresponding point directly across this line from it at 1.50. Or this point at 1, 2 has a corresponding point directly across from it at 2, 1. And even coming out here, this intercept at negative 3 has a corresponding point directly across from it at negative 3 on the x-axis. So anytime that we have two inverse functions, their graphs are going to be reflections of each other over this diagonal line. And what is this diagonal line? Well, this is the line that crosses through the origin with a slope of 1. It goes up 1 over 1. So this is just the line y equals x. So anytime you're graphing a function and its inverse, they should be reflections of each other over the line y equals x. So again here, just in words, the graphs of a function and its inverse will be reflections of each other over the diagonal line y equals x. Which means if you want to easily graph the inverse of a function, all you have to do is find some points on the original function and swap the x and y coordinates. So like we saw here, this point at 1, 2 had a corresponding point at 2, 1. This point at 0, -3 had a corresponding point at -3, 0. So just like when we're finding the function, we switch x and y, you can do the same thing with the points. If you're graphing the original function, to find the inverse, just switch x and y. So our point would go from the coordinate x, y on the original function to y, x on the new function. Or a little bit more concrete example, if I had a point at 3, 4 on my original function, there would be a point on the inverse at the point 4, 3. So just like with finding the actual function, all we have to do is swap x and y. So let's just try a couple more examples here. Sketch a graph of the inverse of f of x equals x squared plus 2. So I'm not asking us to sketch the original function here. I actually just want to see the inverse. But we're still going to need to start by finding some points on the original function so that we can swap them in the inverse. So let's start with just f of x, the original function, and we're going to make a little xy table. So I can tell that this is going to be a parabola because it has an x squared. It's a quadratic function. So I want to get several points just to make sure we can see the curvature there. So I'm just going to pick some x values, -2, -1, 0, 1, 2. So if I pick x is -2 and plug it into the function, -2 squared is 4, plus 2 would be 6. -1 squared is 1, plus 2 would be 3. 0 squared is 0, plus 2 would be 2. Then 1 squared is 1, plus 2 is 3 again. And 2 squared is 4, plus 2 is 6 again. So these would be points on the original function, which again is not what we're trying to graph. We are trying to graph the inverse. So now I'm just going to take these and invert them, swap the x and the y. So the point -2, 6 on the original function would give me a point at 6, -2 on the inverse. Then 3, -1. Then 2, 0, 3, 1, and 6, 2. So if I'm graphing the inverse, well, my x-axis doesn't go out to 6, so it's going to be out here somewhere. 6, 2, 3, 1, 2, 0, 3... Sorry, this original point should have been 6, -2. Then 3, -1. So what I should see is a parabola that is turned on its side. And just if I want to double check to be sure, maybe let me think of my diagonal line here at y equals x. And we should see a reflection. So the problem didn't ask us to do this, but I just want to check to be sure. So -2, 6, -1, 3, 0, 2, 1, 3, 2, 6. Yeah, it looks like this is just this original parabola reflected over this diagonal line. So you can see again, the point 1, 3 has a corresponding point at 3, 1 when we flipped it. So we can be pretty sure our graph of our inverse is correct here because it's just a reflection over the diagonal line. So to finish us off for today, I want to show you just what this will look like when you do it on Delta Math. On Delta Math, it will say, graph the inverse of the provided graph on the accompanying set of axes. You must plot at least 5 points. And then on Delta Math, you're just going to click the graph to make a point. You can click it again to erase it if you made a mistake. So you're not told what the function is here, you're just given a graph, and you're asked to graph the inverse. So what you'll need to do is identify some points on the original function, and then swap the coordinates. So for example, this point right here, this intercept point, is 0, 4 on the original function. So if I'm trying to find the inverse, I would swap those, and that would become 4, 0. So I would click right here at 4, 0, and it would put a point. Then there's another intersection point there at 0, 8. Whoops, sorry, this was 0, 4 to begin with, not 4, 0. 0, 4. And then another one at 0, 8, so I would swap those to get a point at 8, 0. So 8, 0. I still need to do at least 3 more points. So maybe another good one to do would be this vertex point right here. So that is the point -4, 6. So I would switch those to get 6, -4 would go on our graph. 6, -4. And I still need to find at least 2 more points. So I'm just going to look for places where it looks like it's a nice whole number coordinate. So I see one right here at 5, 3 has a nice whole number coordinate. So I'm going to swap those and do the point 3, 5. So 3, 5. And there's another one here at maybe 5, 9. So then swap those. 9, 5 will be on our graph. So 9, 5. I'm just going to clean this up a little bit. And then on Delta Math, as soon as you plot that 5th point, it will automatically draw the graph for you. So we'll be able to see it is the same shape, just reflected over this diagonal line. So, this part of the line that was underneath the diagonal line, or this part of the graph that was underneath the diagonal line, was reflected up here above the diagonal line. And this part that was above it gets reflected down here below it. So we do have this nice reflection here. It gets a little complicated to see when you are kind of overlapping that diagonal line, but as long as we swap all of our coordinates correctly, you should be able to graph an inverse correctly. So give this a shot on Delta Math. You just have some of these problems to do for today. I'll add more stuff kind of reviewing the last couple weeks because we will have a quiz in the middle of this week. So let me know if you have any questions, and I will see you tomorrow.